welcome to the 2021 Virtual Christmas Summit, brought to you by Boscoyo Studio. And this presentation here is sponsored by Wired Watts. While our presenter is doing the presentation, please do not unmute or interrupt, but feel free to put any questions or discussions in chat. So right now, this presentation is brought to us by Paul Thomas, and he's going to talk to us about deeper diving into networking as it relates to X-Lights in our shows. So thank you, Paul, and take it away.
Thank you for the introduction. So what I would like to cover is some more topics that are typically overlooked when we talk about networking for X-Lights specifically. Some of the things I'm going to cover is the differences between routing versus proxying as far as the show network is concerned. I'm going to go into both how to configure them and how they differ, like what is the impact of each. The same for unicast versus multicast. And I think I'm going to spend a lot of time on the different protocols that we're going to use over the network, specifically E131 DDP. Because I think people are going to be surprised by the amount of bandwidth that is not used on the network when it's going. And then lastly, I'm going to talk about show networks in general. When do you absolutely need one? What are some good reasons, based on my personal opinion, to create one? And what are some bad reasons based on my opinion? Again, these are just my opinions. You don't have to adhere to them. And either way it goes, it'll be the right answer. So what about me? Why should you listen to me? This is my third season with X-Lights. I have roughly 20,000 pixels in my show. Last year, I grew from 4,000-ish to, added roughly 16,000. So it's a fairly significant increase. My day job is a principal network engineer. Throughout the day, I sit in front of various network lab gear, doing test and certification. So I'm very familiar with pretty much any network protocol, as well as how to monitor it. Regarding certifications, I have quite a few, everything from CCIE to AWS, Azure, Red Hat. I am very much a nerd. And hobbies outside of the show stuff, honestly, this is my hobby. I like to hang out in the official Zoom room with quite a few of the guys on here. And other than that, I like to do computer gaming and tinker around with Python, which is a programming language. Before we start talking too much about networking in general, or actually your show network, I think it's important for us to understand a little bit about the network devices and how they interact based on the packets that are flowing through them. I'm going to skip over the physical layer. If you're talking about the OSI model, that's going to be your layer one. That's just going to be your Ethernet cable or your RF between your wireless and your router. You don't need to worry too much about that. Typically, that just works or it doesn't. That's a very binary issue. Switches, however, those are going to be the first smart device really in your network stack. They're going to be layer 2 devices, and they rely only on data that's on the Ethernet frame, which is layer 2 of the OSI model, specifically called the data link layer. The only thing that your traditional home switch is going to look at is going to be your destination MAC address. And that is going to be some hexadecimal digits that are burned into the firmware of your Ethernet port or your wireless port. And if you'll look at the screen at the top right, I've got a packet capture that I did just off a random packet on my network, and it shows the destination MAC address starting in 4E81, ending in 2575. Whenever my switch receives that packet, that is the only, or that frame in this case, that is the only thing that it cares about in the entire packet, at least at the house. I'm not talking about any enterprise or service provider stuff. That's well beyond the scope of this. So it's going to look at that MAC address. If it has that MAC address in its forwarding table, that means he knows what physical port it's connected to. He's just going to send that packet out that one port. If it does not know where that MAC address is, like if it's not in its CAM table, he's going to then flood that out every single port that is up. However, as soon as it receives a packet back from the device, he's going to learn the that MAC address on the port that it's on. So for example, if I'm on port 1 and I'm sending this address and it doesn't know, it's going to flood it out all, let's just say 12 ports. When the device that has that MAC address receives that packet and responds, he's going to learn the device is on port 2. So any future communication between my computer ending in MAC address of 010A to the host ending in 2575, it is only going to utilize traffic between those 2 ports. That is a very important concept. If it's not doing that specific function, then you have a bridge where every single frame will always go out every single port. If you've got a bridge, just go and throw it in the trash. Go to Walmart, Best Buy, spend $40 on a new switch. Just do it. You'll be happy. The talk earlier today briefly covered VLANs. So I'm going to add just a very small tidbit. The bottom shows the typical frame as the spec is concerned. If your switch supports VLANs, it must be a managed switch. Otherwise, it's just doing dumb switching, and the VLANs won't be doing the right thing as far as the data on the network is concerned. And if there's a VLAN tag, then the Ethernet 2 frame will become an 802.1q frame. And that VLAN tag is going to be shimmed between the source MAC address and the type of the packet, which is 2 octets. So it'll increase the packet size by basically 4 bytes. Moving up the OSI model to routing, this is going to be a layer 3 device. The only function of a layer 3 device is to allow traffic to go between 2 different broadcast domains. I didn't cover it previously, but a VLAN is a way to logically separate one switch into multiple broadcast domains. A broadcast domain is a subnet. Historically, like at your house would be like 192.168.1.1 all the way through 1.255. That's one subnet, and 192.168.2.0 all the way up through 255 would be a second subnet. Since traffic on a subnet communicates directly together, you have to use a router. That's the whole function of a router, and it does rely on mostly the destination IP address. I did include a snippet of the IPv4 packet header on the bottom left of the screen, just so people can know what other information is in there, but all of this is well beyond the scope of this discussion. But on the right-hand side, I do have a snippet from Wireshark, and I'm gonna show this again also later in the presentation. And you can see that in this particular case, my computer's IP address is 192.168.86.110. And the specific destination that this packet's headed for is 192.168.86.176. So what happens is when the computer needs to reach a device on this same network, in this case, 192.168.86, he will first look in his ARP table. And what that is how a MAC address is tied to an IP address. If the computer does not have that linkage already known, what it's going to do is send out an ARP request for that. Essentially, it'll send data to the destination MAC address of all Fs or all ones, if you're talking binary. And the device that responds will then be learned into the computer's MAC table or ARP table, and then all future traffic will be forwarded to that ARP address or MAC address. Not very much of the show network relies upon TCP, which is the next level in the OSI model, specifically the transport layer. The only thing as far as all the stuff that you're doing on the show is concerned is the management of your controllers. So anytime you push a configuration change to your controller via XLite, it's going to make a request utilizing TCP. When you're actually sending the show data over the network, that's going to be through a different protocol that I'll discuss in a second. But TCP is going to be your stateful protocol. It's going to be a lot less efficient than your show network because it has to keep that state. So there's like a 3-way handshake every time your computer or XLights in this case needs to talk to the computer. There's going to be a 3-way handshake with a SYN, ACK, and an ACK. UDP, that's going to be the bulk of what we see on the show network. Again, this is going to be a transport layer section of the OSI model. And the only thing that's important in this is that we just know that E131 and DDP and even the multicast packets, honestly, they're all going to be UDP. There's no state in the connection. When I say state, I'm talking about the state means there's no the controller doesn't send anything back to Xlights to let Xlights know that a packet needs to be retransmitted, or if a packet was dropped. The controller just assumes the next packet's going to come, and when it does, great. If it doesn't, that's fine as well. That's the problem of the sender. It's not. It's completely outside the scope of anything that our lights need to worry about. So as we get started, I'm going to talk about some very basic show network. In this case, it's like your typical show network. The computer, in this case, is going to be on the subnet 192.168.1.0. And that's going to be everything you see north of the wireless interface of the FPP. I've kind of got it drawn out on the right-hand side of the screen, and I'm going to use this same drawing throughout the next couple slides to discuss some issues. But I do want everybody to be sure they're on the same page, that the show network is physically separated from the home network. The show network subnet is 10.1.1.0. In this case, the controller can be really anything. And in the middle between the home network and the show network is going to be an FPP-based device. Typically, this will be a PI, but it could be a BeagleBone if you've got a wireless and an Ethernet port installed in it. And then on the top right of the drawing is going to be your internet router. This is going to be something you get from the cable modem, or from your, from AT&T or whoever your wireless provider is. This is going to be your route out to the internet. So these four devices are going to let us cover most of the issues that we're going to see. The computer in this case, although I've got it depicted as being Wi-Fi only to the internet router, it could be wired as well. It'll be the same result. It's not going to change anything as far as how the various higher levels of the OSI layer are concerned. So with some very baseline things taken care of, the question is, why doesn't this just work? So what does the computer know about? He knows, in theory, the MAC address of all devices on his subnet, 192.168.1.0. So he'll know the 192.168.1.2 address of FPP. He'll know the IP address to MAC association of the router. And that's it as far as the things that are on the same subnet are concerned. He also has a default gateway defined. What that means is if it's an IP address that's outside of his own subnet, so anything that does not start with 192.168.1, he's going to send every bit of that traffic to the internet router. And then the internet router is going to make a decision from there based on his routing table, what to do with it. If he doesn't know about it, in this case, he's not going to know about 10.1.1.1, which is your show network. What that router is going to do is send it to his default gateway. In this case, it's going to be whoever your internet provider is. And then they're just going to drop it on the floor because it's a private IP address, and they don't care about routing that traffic for multiple reasons. So that's why the computer does not have any connectivity to the show network. It has no knowledge of 10.1.1. It's outside of his own subnet. It's going to hit the default gateway and go to the internet. Looking at it from the controller's view, though, things are a little bit differently. Typically, whenever the controller comes online, or whenever you initially configure it, you will put a default gateway in there. Generally speaking, that's going to be the IP address of the Ethernet port of your FPP device. In this case, it's going to be 10.1.1.1. The controller does have knowledge about how to get to things outside of his subnet. He's going to send it to the default gateway, just like the computer will do. His default gateway is FPP. So FPP will then send traffic to the appropriate device, whether it's the computer on the same subnet or the router. So the controller, based on that, has one-way communication to everything northbound of the FPP in this instance. But what will happen though is once the controller, for example, tries to reach, let's just say the computer, when the computer will receive that packet coming from 10.1.1.2. However, the controller will never receive a packet back from the computer because the computer is going to send it back out to its default gateway. And again, the internet router is going to send it out to the internet, which the provider will drop. So that's why things don't just work. And that's also why the controller has one-way communication to all devices on your home network. I hope everybody is, hope I did a decent enough job of explaining that. So I'm going to assume I did and move forward. So there's a couple ways to address this. We can set up a static route on just your computer. The command varies based on the computer that you're using. However, the syntax on FPP is always going to be the same. What you'll do is go under status control, then under the network page, scroll to the very bottom and just put a check and enable routing between interfaces. As soon as you do that, the Pi is going to be able to route, act like a router, essentially, nothing more, nothing less. It'll route packets. But that doesn't create all the connectivity that you're going to need. You're also going to have to configure your computer. So if you're on Windows, you'll need to issue the route add command. You'll need to run this as administrator. So what you'll do is you'll type in route add, in this case 10.1.1.0, the word mask, 255.255.255.0, and then put the IP address of the wireless interface of your FPP device and the letter P. The letter P is important because it makes the route persistent, meaning it's going to stay there after it reboots. If you're on a Mac, things aren't quite as efficient because once you add the command, it's not going to be there after a reboot. So you'll need to be aware to do that after you reboot the device, the Mac. But the command to do so is sudo route tack in add -net, the destination subnet with solder notation, which is the /24, and then the default gateway for that subnet. In this case, it's the wireless IP address of the Pi again. If you're not aware, the /24 is the exact same subnet mask as 255.255.255.0. It's just the number of bits required to make all the 255s. There's a downside to doing it that way, in that just a single device has connectivity to your show network. That may be what you're expecting to happen. It may not be. Personally, I work for multiple computers, so if I'm going to address this via routing, I'm going to make that routing change on my router. In this case, the device at the top right. Unfortunately, not every device that is a router supports that. Pretty much anyone that you get from your internet provider is not going to support it. So you'll probably be buying something, something different. I personally have a UniFi system. I would not recommend that to Joe User, honestly, because Joe User doesn't need to know all the nuts and bolts to configure that are required to know to configure UniFi. But if you're interested, UniFi has been a very stable system for me, honestly. But and the configuration is going to be different for every single router manufacturer. So there's no real way to answer it. You just have to know that you need to configure a static route for your show network subnet, again 10.1.1, to get to it via its gateway, which is 192.168.1.2. The only downside to making this route, this static route on your internet router, is that once you do so, that traffic is going to hairpin. So whenever you send traffic from your computer, he's still going to send it to his default gateway, which is internet router. That guy's going to do a route lookup in his forwarding table and send it to your Pi. So now this traffic is going both in and out the same physical port. That's not necessarily a problem unless you've got a lot of traffic on that port. That's going to be relevant to the speed of that interface itself, whether it's a 100 meg or a 1 gig. If it's a 1 gig interface, it's likely a non-issue completely. The The big benefit to routing versus proxying is you don't have to configure anything in Xlights, and possibly every single device on your home network, depending on how you configure it, is able to access your show network. That to me is the big win over proxies. The other option is proxies. The way proxies are different than routes are that proxies are actually done at the application layer or layer 4, depending on what you're doing, but typically at the application layer. So what's happening is with a route, you're sending the traffic, the destination of the traffic is actually the IP address of your controller, 10.1.1.2. If you're going to configure a proxy and use a proxy, you're actually going to send the traffic to the destination IP address of your FTP instance, 192.168.1.2. And then that FTP device will then act like a repeater and send the traffic to the controller. One side effect of configuring a proxy on the BeagleBone or the Pi is your controller doesn't technically need a default gateway or even the correct default gateway, because he's going to see traffic always coming from the Ethernet port of the Pi. So that's going to be a ARP. It's going to be an ARP reply as opposed to a routed packet. And the return traffic to the computer is going to see traffic coming from 192.168.1.2 and not from the controller itself. So the packets are being completely rewritten at layer 3. In order to configure a proxy, what you're going to do is you don't need to configure routing on FTP when you're doing proxying. You can, but there's no benefit in doing that. All you need to do is go to your status control page and then scroll down to proxy settings and then put in the IP address of your controller, or if you have multiple controllers, you're going to add them there and then click on save. And then one change you'll need to make in the Xlights is to configure the proxy. That's going to be on the controllers tab. And you'll need to do this for every single controller that might be behind the FTP on the show network. There's no reason you can't have more than one controller on the same show network. There's also no reason you can't have more than one show network. So once you make the changes in FTP to enable proxies, I went ahead and covered already the fact that FTP is going to be participating in the show network, but it's also going to be participating in the management network. So when you want to access the web page of your controller, you're now going to see the IP address of your FTP instance, the wireless instance of your FTP instance in the front of the URL. So it's going to be your wireless IP /proxy / the IP address of your controller. So all management's going to be doing it that way. And if you make a configuration push through Xlights, it's going to hit that same address. You just don't see it. That's all behind the scenes. Another impact is no matter how you have your controllers set, whether it be E131 or DDP, all the traffic being sent to the proxy IP address will be DDP. The FTP will then take that DDP traffic it receives, and based on how his the controllers are configured on FTP, he will then send those out by E131 or DDP on the show network. Either one will work. But again, nothing is routed between your computer and the controller. The FTP is actively participating in all those packets. So I'll put together a quick little summary of static routes versus proxies. The big win for me for static routes is there's no config required on within Xlights. Also, your show network's gonna have internet access. The reason that is important is if you have a Pi on your show network, they have a really hard time at keeping timing in sync. When I say timing, I'm talking about like scheduling time, like date and time, not scheduling of timing data for the show. So in order to fix that, there's two ways to do it. You can either utilize an NTP server, which is network time protocol, and it will pull the time periodically from somewhere on the internet, or you can buy a real-time clock. So if you don't have a network access, internet access from your show network, you are now pretty much required to have a real-time clock on your Pi if your master is on your show network only. I probably wouldn't do that, but that is what some people have to do. The downside is, it's a little bit more complicated to set up. The proxy overall is simpler to set up. You make sure you have to make the change in a couple of different places, within both FPP and in XLights. But both places, that's a one-time setting, and then you're done. The big downside to proxies is I've had some intermittent FPP connect issues, especially if you have a remote FPP instance that's only on the show network or like a remote cult controller. So that's something to be aware of. So this is some of the, how do I say this? So Pixel protocols that we're going to use, the old school stuff is all going to be your E131, formerly known as SACN. This is going to be, based on the universes and start channels. And typically what you'll do is add your controller. You're going to say, I want this many universes to go to your controller. And you're going to say how many channels are going to be in a universe. The default is 512 channels. Unfortunately, that's not divisible by 3. So we generally just ramp that down to 510. But in either case, that'll work just fine. And E131 will support multicast, but I don't think anybody uses multicast. There's some trade-offs to doing that, which I'll cover later. DDP, everything is going to be absolutely addressed. So when I say that, there's no concept of a separate universe or start channel. Channel number 1 is channel 1. Channel 513 doesn't go into universe 2. It's going to be channel 513. The benefit is it's much more efficient on the network. And the reason it's much more efficient is every single universe on E131 packet or E131 configured protocol is going to be one packet. So if you've got 100 universes going to your channel, every time interval, you're going to have 100 packets put onto the network. If you're using DDP, however, that's going to send as large as a packet possible per your MTU size, which is something I'm not going to cover here, but typically it's 1500. So you can have up to 1,440 universes in one packet for DDP versus the up to 512 on E131. Another feature that DDP has is the concept of absolute addressing versus one-based. What that means is when you're looking at XLights on the controllers tab, it's going to show every single, it'll show every single universe number all the way through, or every single channel number for each controller. So controller number 1 will be receiving, for example, channels 1 through 100. Controller number 2 will receive channels 101 through 200, for example. There's a downside of doing that in that you have to really track the configuration of your controllers within XLights. So if you have two controllers and you make a single change to a line item on your first controller in XLights, that's going to shift all the channel numbers for the controller below it. So now you're chasing channels throughout XLights. I'm going to show you this in a demo in a bit. But you can turn on a knob that allow you to do what they call one-based numbering. So even though XLights in the controllers tab will show the second controller starting with channel number 201, for example, when it sends that data to the controller itself, it'll actually send that controller channel 1 instead of 201. The benefit of that is you don't have to worry about adding or removing props. The significant downside is that does not work at all with multisync. So if you're doing multisync, forget the concept of one-based. And I think everybody that's doing DDP is doing multisync. And just so you can see theoretically the benefit of E131, actually of DDP over E131, just using the 100 meg link on the bottom right corner of this graph, a chart table that I snagged from a website, you can have 87,000, almost 88,000 pixels on a 100 meg link, whereas E131, you're losing roughly 30,000 pixels. That to me is significant, or 20,000, hate math. So multisync is going to be utilized if you've got more than one FPP-based device, or if you're using Xschedule and a single FPP device. The benefit is you'll upload just the sequence data or FSCQ data that's relevant to your FPP instance, and it'll be stored on the SD card. The only data that's sent between the master be it an FPP or X schedule, to the FPP device is multicast packets. And there's a packet capture shown below, and you can see that it's either 2 or 3 packets sent every second to that device. And if the seconds in this case are where you see 7 dot, 8 dot, 9 dot, that's how long I've been running this particular packet capture. But you'll see there's not much data at all. It's literally two or 3 packets a second, which will take essentially nothing on the network. I mean, it's the equivalent of pinging a host. There's no benefit to moving this from Ethernet to wireless unless you've got poor wireless signal somewhere. The way this works is that the master is constantly sending these out. They're sent via multicast. Your switch or your wireless router will send that onto the network, and then any devices that are subscribed to the multicast address of 239.70.80.80 will receive that data. So if you've got one FTP instance or 12, you're going to receive the exact same amount of data on the network. Then as the FTPs are receiving that data, they'll compare where the state is of the sequence. So the contents of this packet says, I'm playing this sequence X and I'm currently at timestamp 1 minute, 13 seconds, and some milliseconds. That's the only thing being sent. As the timing of your remotes slips further or a little bit behind or a little bit ahead, it will drop sequence data or skip forward in sequence data so that it stays in sync with its master. If you're having problems with multicast, you can change it to unicast, and that's both available in X schedule and on FPP. One interesting note is whenever Dan and his team were creating this, that 239.70.80.80, that actually, the 70.80.80 is actually FPP in hexadecimal, which I thought was pretty clever. So I did a test just so I can see how much data is really used on my personal network. I didn't want to trust that chart that I was given. So what I did is I built a 10,000 pixel matrix, slapped the butterfly effect on it, and sent some data. So first I did it with just E131, and I left the auto size checked. And when I did this, I was receiving roughly 12.3 megs a second to the FPP device. And these screenshots that you see on the right-hand side, that's coming from my Unify device where the FPP device is connected to. So E131 auto size, roughly 12 megs a second. If you turn off the auto size and went ahead and just set it to a static universe of 96 universes, even though you're not using universes 60 through 96, all that data is still going to be sent from Xlights. It's still going to be included in the FACQ files when they're created. And in this case, that bumped the amount of bandwidth used from 12.3 up to 16 megs. So that's just useless data that does not need to be sent to your controllers. If you convert over to DDP, just literally no other changes other than changing the drop down in DDP, controller tab to DDP, it drops down to roughly 9.5 megs a second. But really, I'm willing to bet most people on this bridge or on this call are using much less than 10,000 pixels. So based on that, keep that in mind when you are deciding if you need to make a show network or not, because this is really nothing. Even for a 100 meg interface, which is going to be your Falcon controllers, there's no reason to build a show network just for bandwidth reasons alone. I also included multisync, but really that traffic wasn't really measurable at all. So it's 16 bits a second, which is nothing. So any questions before I start into a demo? It's going to take me a second to get that opened up. So anybody awake? All right, so.
Oh, yeah, you were quick. Well, I was going to ask if anybody had any questions.
Nope, go for it. I've got time to kill. Crickets, cool. So what I've got here, this is the kind of the scenario that I discussed briefly. I've got a Falcon controller this is exactly like it was depicted in that first couple slides. So I've got a Falcon controller. In this case, I do have it configured via proxy. This effort's really going to be showing DDP versus E131. And I also have a culp, in this case K40, and he's configured for DDP. So what I'm going to do is I'm going to send traffic to both of these here 10,000 pixel matrices. So if I mouse over it, you'll see he's got, apparently I messed up on my math, but they've got almost 10,000 pixels. I've got the butterfly effect set on both of them. So what I'm going to do is I'm going to fire up Wireshark over here on this tab. It'll come over, and I'm watching for traffic being sent to the IP address of both of my controllers. So right now there is 0 traffic, and I'm going to click on this one, the matrix, which is allocated to the Falcon F40 at 192.168.86.151. So as soon as I do that, we're going to see traffic coming in. So I'll put the lights, and you can see all kinds of traffic. But if I go into here and go to statistics IO graphs, which of course opened up on the wrong window, we can watch this kind of draw itself out. And I cannot figure out how to make Wireshark change the graph, but you can see that it's sending data at the rate of 10 to the 6th bits per second. I'll math that out for everybody. And that's roughly 10 megs a second. I've also got that in my Unify system as well, so we can see that. This should update here shortly. But as it's sending out, one thing to note is that the traffic, even though it's configured for E131, it's coming in as DDP. The reason I know it's DDP is because of the size of the packet. It's 1,450 bytes. If it was E131, it'd be roughly 510. And I'll show you that here in just a second on my culp controller. But you can kind of just see the trend line here for this E131 packet that's being proxied through FPP. So go over here to X lights. I'm going to swap this over to be sent to the matrix 2, which is going to my culp. So if I go down to the bottom, you'll see traffic is now destined to this 184 IP address, whereas previously it was being sent, apparently it scrolled off. Unless I messed up, 151.184, that's right. So again, if I go back to the packet graph, the traffic graph here, it's going to be the same amount of traffic. You can see this blip where it stopped sending traffic when I was changing it from one controller to another. But the reason there's no change in bandwidth is because even though the first one was configured for E131, it's being proxied. So it's being sent from X lights as DDP, just like the culp controller is being configured for DDP. However, as soon as I change this culp from DDP to E131, got auto SAS turned on. So in this case, it's going to use 59 universes. Render this real quick. If I turn this guy back on, my traffic pattern should be much higher. Yeah, so it's roughly 20% higher just by changing it to E131. There's no difference in what the way the show performs. It's just additional data that's on the network that doesn't need to be there. And if you're doing it the really old school way, where you've got, so 2 years ago, pretty much everybody by default was going to hard code and not use auto SAS. So if I just go back and set this to be 96 universes, actually, let's leave that back where it was. Change this to 96 universes. That one change is going to add additional traffic to the network that does not need to be there. Moving on over here. And it's not there. Fantastic.
Render.
Still not there. Live demos. It was there previously. I took screenshots. So take my word for it. There'll be additional data on the wire. Maybe because this is playing direct from X lights as opposed to doing sequence data. Um, so any questions about how to configure routing or how to configure proxies? Because I've only got a couple more things to share. That's going to basically be my own personal lessons learned from last year to this year, and things I'm gonna change.
Yeah, I've got a question. I'm currently set up with a separate network, show network, and I've set it up for proxy. But as I understand, just so I understand it, if I set up static routing on my Mac, I can eliminate the proxy settings. Is that correct?
You can eliminate it. The issue that you're going to have though, since you're on a Mac, every single time you add a static route, or every time you reboot your Mac, that static route's going to be lost from its memory because it's not saved persistently. So you have to re-enter that static route every time, unless you put the static route on your router at the house.
Right, but in most cases, that's not an issue. I mean, the only reason I do that is for two-way traffic, right?
If you don't have that route there, you won't be able to send any data to your controller from X-Lights.
Oh, okay. I thought it was just the traffic coming back from the controller.
No, it's actually the other way around. So the controller is going to know how to reach your computer. It's the traffic coming back from your computer itself won't be able to reach the controller.
Okay.
And honestly, my preference is proxies versus routing due to stuff like that. You don't have to worry about the routing, which a lot of people don't fully understand the impacts of, and forget that they have routing enabled come next year when it's time to set it up. Whereas if it's proxied, all that's saved both in your X-Sites config and in your network config.
So I'll leave it as is. Okay, thanks.
Mm-hmm.
Hey, Paul.
Yep.
One thing the gentleman just brought up was about Xscheduler, or brought to mind something about Xscheduler. If you're running your computer on your home network running Xscheduler and you have a proxied setup, you're still running in proxied mode, but you never touched on the throughput of the home router and what that could cause when it gets degraded by running, say, Xscheduler on the home network and gaming and streaming. So you didn't touch on the throughput of the device at all.
So I will do that right now.
All right. Jumped ahead of you. I'm sorry.
That's good. Appreciate it. So the most common, and I think, at least in my opinion, it's a valid reason for a show network is that you've got typically a Falcon controller somewhere, or even a Hinkspix or any brand, it really doesn't matter, but you've got it physically wired to a Pi, and that Pi is wireless back to your house. That is 100% a fantastic reason for a show network. Another reason people like to say for a show network is security concerns. I've also got that listed as bad reasons, and I'll cover that here in a second. But people are worried that somebody's going to gain access to their show network and then wreak havoc on their home network. If you're going to take proper precautions, that's all good. Bad reasons. So to build on what Scott mentioned is bandwidth concerns or latency concerns that's caused by other traffic on your network. Personally, I run everything on a flat network. There's no show network. The reason it's not a problem is because I use a switch that I discussed earlier on in the slide that does the right thing. When I say does the right thing, it will only forward traffic based on the 2 ports that the traffic is required to be on. If you have if one of those 2 ports, however, in my case, has, or at least tries to receive more than 1 gig of traffic, yeah, then I'm going to have a problem, and I need a different physical interface to that switch. But if you've got somebody watching Netflix or anything like that, and your home network is wired, there should be zero impact on having a show network. Another one is Wi-Fi. So your wireless network is very susceptible to bandwidth issues. So if you've got poor wireless coverage and you want to add a different wireless router to cover your show, that's fine. That's a good reason. However, if you're going to just add another SSID to the existing router, that may not give you all the benefits that you're expecting, because wireless antennas are half duplex. And what that means is they can only send or receive traffic. They can't do both at the same time. There are some other technologies called MIMO, multiple in, multiple out. What that does is essentially bonds multiple antennas into one larger antenna, or what you may have is multiple radios and multiple antennas, which typically your Unified gear has, a lot of your newer Linksys gear has, even the Google Home stuff has. That's one way they get past being able to not send or transmit at the same time. But even if you have multiple antennas, your router, your access point should be sending traffic to the appropriate radio for that destination stream. So if you've got one person streaming Netflix and then you've got your FPP also receiving traffic, that should take up two separate radios and two separate wireless frequencies, therefore not to step on each other. There's no guarantee the router will do that or the access point will do that. So that is an issue. The reason security concerns is not necessarily great is unless you're going to be adding a ton of firewall rules, all you're doing is adding complexity. You're not gaining much benefit. So I'll kind of not a fan of that. I'd probably propose that you better secure your home network instead. Last one is network stability. I see quite a few people in the Zoom room pretty much gold plate their show network with some fancy enterprise gear, while their home network is running on low end gear provided by their internet provider. Instead of gold plating your home network, your show network with this enterprise gear, why not upgrade your home network to be that same enterprise gear if that's the route you're going to go? That way, everybody in your household that's using your network can get the benefit. The show will still perform perfectly fine because it's now on that same gear. So, Scott, did I answer your question or no?
Sure, clear as mud. I was leaning towards the backplane throughput. So everything gets combined together and your backplane has to be fast enough to handle all of that traffic, which you showed that the show isn't as much traffic as we may think. But when you start adding gaming and streaming, now these little home routers can't really keep up with the backplane bandwidth.
I think so.
Before you answer there, Paul, hold on, I just want to give you the 10-minute warning. We do have a break afterwards, so we can go a little bit, but just to give you fair warning.
All right, move on. That's more of an advanced thing, but if you need to move on, go ahead.
No, I'm good. So that's more of a case-by-case thing. So I hesitate to say that's always a problem. I've found even on my $10 Netgear switch that's as cheap as possible, I couldn't get any cheaper, I had zero resource contention between ports. When I say that, I could send traffic at line rate through every single port on that switch without issue. The only time it would become a problem, let's just say I had ports 1 and 2 sending traffic at 1 gig to port number 3, right? Because port number 3 can only output 1 gig of traffic physically. So that in that case, the backplane is oversubscribed. And I did test this with a traffic generator at their office because I have nothing better to do on time. But so switches, I would always expect those guys to not have any backplane issues. Now, when we start talking about routers, things get more complicated pretty quickly because a lot of the routing function is done in software these days, except for some of the newer ASIC-based home stuff. But honestly, I would say don't build a show network for that reason until it is a problem. And even then, it's just a sticking a pie in the middle. It's not too much work to do. Does that help?
Paul, can you speak to the complexities of adding your system to a mesh in your home?
Yeah, so mesh networks have other complexities. So what they often do is sacrifice an antenna or two for the mesh functionality. So all that's really acting like is a repeater. Um, when I'm talking about mesh networks, I'm talking about like your Google Homes. That's the one I'm personally familiar with, or the Unify mesh networks. So what they do is they create a backplane going back to your home router through multiple Wi-Fi hops. So now you, instead of having, for example, on the Google Home, I think it's 9 Wi-Fi antennas. You're cutting that in you're taking a segment of those antennas and making them your backplane. Uh, Now, if your mesh network is home run Ethernet back to your router or your switch, then all the mesh problems as far as losing antennas for the backplane go away. So that would be the ideal case. That's honestly how I run my network, and the roaming, at least on the Unify, works as I walk through my house. The my phone or my laptop will essentially jump from access point to access point, depending on where the signal is best. But just the fact that you have a mesh network, the configuration for your FTP won't be any different. The difference is how the access point that you happen to be connected to is connected back to your home router. Does it go through another wireless hop, or is it the first hop wireless hop on the line? If it goes through more than one, you're going to have degradation. Thank you, thank you, Trevor. You're correct.
Paul, I want to thank you for what you shared here and everything like this. This is really good stuff, and I appreciate that. My display is spread out quite over a distance. We have a community show, so we got 10 homes on across, on 2 sides of the street, right? Both sides of the street.
Mhm.
And so I've built. I tried one year to do a Wi-Fi mesh and to extend to get to across the homes and stuff, because I like that idea of not having copper between the houses and different things because of lightning issues and stuff where we live, right? So I like that idea. The problem I ran into is it was so unstable. We have other engineers in the neighborhood that have other radios and things like this that cause me issues. But so I went, got my own network where it's, we run Ethernet line, a Cat 5 or 6, and this serves us well. Obviously, what you showed is the bandwidth needed across all of that is a lot less than the gigabit switches that I have in places to support the number of controllers, right? So it's way overkill, but why buy 100 meg when I can get a gig for the same price about? So, but what I was wanting to do is I got neighbors that are on even further down that want to join in on the community. And I was looking into that low way connectivity and just just do the multi-sync across that. Have you had an experience with that? What do I need to watch out for?
I personally haven't used that, but I do know that there are like some home people with decent antennas that actually communicate from their house to satellites in the sky using LoRa. Now, granted, it's super slow rate. I think that's like 300 baud, but in your neighborhood, that should work just fine for multisync. And Dan Culp and those guys have got plugins for LoRa now.
Okay. But way I understand it, it essentially is creating almost a WAN connection on that from this, where a master player is. Am I thinking correctly on that? I mean, it's going to be another network that it's going to have to route across.
Correct. It'll be another subnet.
Okay.
And that's all it is. It's nothing other than a different transport medium.
Okay. All right. Thank you.
Yep. So I've got one more slide I want to show. Kind of the don'ts. Please don't really. Don't create. The biggest one is don't use SneakerNet. That makes everybody's life hard when you're trying to help you. When I say SneakerNet, that is basically putting something on a thumb drive from your X-Lite show computer, walking it over to FPP that's got an air gap, no config, no communication between them, and running it physically separate. We've helped quite a few people in this X-Lite Zoom through a webcam or through somebody holding it with their phone. It's very difficult, and there's no real win in doing that if you can avoid it. There's always issues. There's always reason to do that, but that should be the exception. Also, creating a different VLAN or SSID just because of congestion may not resolve your issue, because the VLAN, you're still using the same physical port on the switch, and chances are your switch is not saturated on that port. And SSID, creating another SSID, you're probably still using the same radios and same frequencies, but that's really a per router thing. And lastly, unless you really want to start understanding networking in more than can be discussed in 45 minutes, don't go out and buy some enterprise gear. It's going to give you a lot of headaches. Personally, like I said, I do use Unify at the house. It works great for me. But then again, I've got greater than 30 years of networking experience. So there's that. But again, if you want to learn networking or you want to just have it, go for it. We will help you, but I would avoid it. And I think that's going to be the last thing that I cover due to time constraints.
Yeah, it looks like we're just about at the end. So we could wrap it up officially. There is a break, so if anybody wants to hang out, but let's officially wrap it up. So yeah, thank you, Paul. That was great. Definitely one that I know I'll be rewatching. And again, thanks, Paul. And thanks to our sponsors, Boscoyo Studio and Wired Watts. Have a good VCS, everybody.